Why are emissions difficult for internal combustion engines? Imagine trying to keep a room perfectly clean while a small fire burns inside. That's similar to what happens inside an internal combustion engine. These engines power most cars and trucks, but they also produce emissions that are tough to fully eliminate. Let's explore why that is. Internal combustion engines work by burning fuel inside cylinders, creating high-temperature and high-pressure gases that push pistons to generate power. This process is complex because it involves many chemical reactions happening at once. When fuel burns, it produces carbon dioxide because carbon atoms in the fuel combine with oxygen. Since this is a natural part of fuel oxidation, it's impossible to avoid entirely unless we switch to different energy sources. Improving fuel efficiency can lower the amount of carbon dioxide produced per mile, but it doesn't stop it altogether. Incomplete combustion is another big challenge. Sometimes, there isn't enough oxygen or the flame gets cooled down by the cylinder walls. This results in unburned hydrocarbons, carbon monoxide, and other partially burned chemicals escaping into the exhaust. These pollutants come from fuel not fully reacting due to uneven mixing, temperature drops, or engine conditions. Incomplete combustion also creates soot or tiny particulate matter that can harm health and the environment. High temperatures inside the engine cause nitrogen in the air to react with oxygen, forming nitrogen oxides. These are very reactive and contribute to smog, acid rain, and breathing problems. Reducing nitrogen oxides often means lowering combustion temperatures, but that can reduce engine efficiency or increase other emissions. Fuel impurities like sulfur also add to the problem. When sulfur burns, it forms sulfur dioxide and sulfur trioxide, which can turn into acids in the atmosphere. Although modern fuels have less sulfur, these emissions still pose environmental risks. From a thermodynamics point of view, the combustion process involves complex heat transfer and chemical reactions inside a confined space. This makes it hard to burn fuel completely and cleanly under all conditions. The goal of maximizing power while minimizing emissions is a tricky balance for engineers. To cut emissions, manufacturers use better fuel quality, optimize air-fuel mixtures, and install devices like catalytic converters that chemically change pollutants. But these measures can only do so much because of the fundamental limits of how fuels burn. In short, emissions are difficult for internal combustion engines because burning carbon-based fuels naturally produces carbon dioxide. Incomplete combustion releases harmful chemicals, high temperatures create nitrogen oxides, and fuel impurities add more pollutants. The physical and chemical limits of combustion mean that some emissions will always be present, despite technological improvements. Understanding these facts helps explain why cleaning up emissions remains a challenge for internal combustion engines.